without the wires in the way. Well, the taper shot. All right, what do we got here? I can hang this on. Nothing. Ready?
Yep.
Okay. Really lightweight fiberglass.
Yeah, it really is thin there.
Yep, it really is. Yeah, my hose are very lightweight. So we're just we put the butyl tape down, and now we're gonna carefully peel the paper off the back so we don't peel the butyl off the aluminum.
That's pretty smart. I would think of just put the butyl tape, raw butyl tape on, you know, and then make a mess.
Right, so the tape lets you make sure that it's bedded hard against itself and against the aluminum. You know, and you can just work a lot more neatly that way. We're still gonna have a little bit that's gonna squeeze out when we get to the end, but I think we should be okay. Not much. All right. Without the wires in the way. Well, the taper shot. All right, what do we got here? I can hang this on. Nothing. Ready?
Yep.
Okay. So last week we took the bar out of there. We cleaned up some of the material that was around there. There was a bunch of blocking in the way that we cleared out. So now we need to get really good accurate measurements to send to Garhauer. So we're going to start marking up where the foundation will be for the baby stay tang. And so we're going to cut a piece of plywood that'll be the exact shape of the foundation, and then that'll allow us to make really accurate measurements about how long the tang has to be. We already know the angle has to be 12 degrees. We measured that last time. But we need to know exactly where it hits on the tang. So, on the backing plate. So that's what the exercise is for today. It's very carefully marking out where the foundation will be so we can get accurate measurements for the foundation plate, the base plate for the tang, and then get those to Garhauer so we can get the piece fabricated. We have some G10, which is a high density epoxy that has fiberglass in it, and we're going to use that actually to make the foundation. So we're going to make a plywood template first, then that plywood template will be traced onto the G10. G10 is pretty expensive stuff to be cutting up randomly. We have that up in the workshop, so when we go up there we'll have all that ready to go, but we'll make sure it fits first with the plywood and then make the G10 foundation.
All right, sounds good.
It's not how a quality builder would have done it.
Right.
So one of the big problems we're going to face is making sure that whatever gets made is going to fit when we're all done. And we have to make a foundation that's going to work with the drawing that we're going to send out to California. I don't think we have the luxury of time of putting the foundation in, drilling it, measuring it, and sending that back out to California. So we're going to cut out a mock-up out of plywood, and we're going to put that in the space. The space is already marked out where we want to put it. And then we're going to take very precise dimensions, very precise measurements. That'll give us a clue as to what those dimensions should be. I'm also going to design that tank so there's a little bit of movement. If it's not exactly where we think it's going to end up, if it's an 1/8 inch one way or the other, it'll still work. So that'll be part of our plan. That's our plan B is going to get designed into plan A. That's it.
All right, good. You're using plywood?
Yeah, we're using
Just regular plywood. All
3/8
right.
inch plywood. This is E10. E10 is actually made for electrical purposes, but it's epoxy and fiberglass that's been highly compressed, so it's very dense. And we're going to use that to make the foundation for the baby stay plate. And if you look at it on edge, it's a 1/4 inch thick, so it's actually the same thickness as the base plate, the template that we made. And so we can test the template and make sure it works, and then we'll cut it out of this material.
And it's heavy. Let me hold that again. Yeah, this thing is a lot heavier than it looks. Oh my gosh, yeah, that's pretty dense.
Well, it's heavier than aluminum, not quite as heavy as steel. It starts out as a very thick layup of epoxy resin and fiberglass that's compressed down to be this material. It has quite a bit of strength to it. And quite a bit of memory, which, unlike aluminum, like for example, if we did it with aluminum plate, we could bend an aluminum plate. This will flex, but it won't break. And we're going to, between this and the curvature of the deck, we're going to have thickened epoxy. So that thickened epoxy will spread out that load across the whole area of the deck. So when we're done, we're going to end up with a piece of E10 that's as wide as this piece of plywood, and which will fill that whole space. And then you'll have an I-beam. With this as the bottom flange, the deck is the top flange. In between will be thickened epoxy that holds the two together. That also provides a flat surface so that when we get the base plate made, the base plate for the tang will sit flat against this. We don't have to have a curved base plate made. So it accomplishes a number of things. We don't have to give Garhauer a very specifically measured curve to make their base plate out of.
Okay.
So this is a very old school tool. It goes back to 1963. My dad bought it when he was fixing up our first boat. It isn't built the way modern ones are. It's really heavy. Modern ones are lighter to hold and are actually more powerful, but this will grind through just about anything. So what we're going to have to do is clean up all the bad fiberglass that's up here.
Because the torque is stronger on here?
Well, it's got a lot of torque, but it's slow turning.
Right.
It's geared.
Right.
And yeah,
what's this made out of as far as what's on there?
well, it's just carborundum, but it's really coarse
Right.
setting. I mean, this.
Yeah, that's rough, yeah.
Yeah. The idea is that you're going to be grinding away all this, just the surface of all this, but you want to hit every surface. So you're going to taper that down where it's all torn here. Mm-hmm. And that's going to be tricky. So you want to get your head below the plane of this so it's not shooting fiberglass in your eyes.
Right.
And you're going to be grinding. Then you're going to take it out here. It'd be nice if this wasn't in our way, but I think that's a solid piece.
Yeah, it is. All right, I'll work around it.
So, but the idea
is to get all this loose strand fiberglass
tapered down.
Tapered down.
Tapered
Okay.
down. So that you're going to grind it till it tapers. So you're just going to be running along here, and it's probably going to be, you're probably going to be running kind of. You can get it in there. Maybe you can. Yeah, it's going to be like you're going to be running like that, right?
Right.
With the edge of the blade just cutting it.
Okay.
And then every surface you want to see scratch marks on. And some of these surfaces, I don't know if you're going to be able to get the grinder in there. You got to be careful it's not hitting the part that shows. So
Right.
so I'm not sure how you're going to hit some of these surfaces, but you're going to have to hit them, which may mean small,
On an angle.
yeah, small swipes.
Right.
You know, they didn't even bother to cut these blocks off. They just slid them in there and snapped them off. I mean, what? Could they have done that any cruder? And
They put one nail through it, yeah.
Well, actually, it's a wood screw, metal, steel wood screw. Give me your screwdriver.
It looks pretty high tech.
So this is what's called door skins. Door skins are non-marine plywood. They're made for the door skins of a door. It's the cheapest, junkiest crap you can buy, and that's how they made that.
But if it does the job is to what?
It does the job for a little while if it doesn't get wet. If this boat was actually used offshore a whole lot, this stuff would have unraveled.
Right.
A friend of mine once built a little dory out of door skins. The first time he had to go up on a beach and he scratched to the paint, the door skin started unraveling. Of course, the whole boat cost him about, in those days, about 25 bucks in wood.
And how do you spell that door skins with that word?
Well, it's door like a door that's hinged. Skin like your skin.
Okay.
So
door skins.
Yeah, it's separate. It's two separate words.
So how's that different than a shimmy? A wood, like a wood shimmy.
Well, first of all, a shim.
A shim.
No shimmy. Shimmy's a dance. Yeah.
Yeah, shimmy, cocoa bop.
Yeah, exactly. So it's being used as a shim, which is shim just means spacer.
Okay.
But they've just used scrap trash
Right.
to make that shim.
Okay. Well, now we got it removed, and so that's going to give us a little more room.
Yeah.
To grind it down. Okay.
Right.
And then we'll put it back because.
Right.
Yeah.
That's what, and you see I marked it where it went.
Right. Yeah.
Okay.
Noted.
So that's going to go in there like that. The trouble with that right now is that we can't even get a good measurement on it. So we're going to have to do something a little more innovative. Turns out the thickness of this plywood matches the G10 pretty precisely. So we're going to be able to take a very precise measurement from the face of this to the underside of the deck, and that'll tell us how much we need to add for the thickness of the fiberglass. The thickened epoxy that's going in there. So I drilled a couple holes, and they're a place where I can take measurements through. When we do the actual installation, we're going to drill similar holes, and we're going to put a wire tie through there, up through the deck, and then above the deck we'll use some wedges, and that's what's going to clamp the G10 hard up against the deck with the thickened epoxy on it.
Gotcha. Good.
So that we don't have to stand here and hold it while the thickened epoxy sets. So I can feel the underside of the deck, and I'm pushing the ruler up against it, and I'm holding the ruler with my thumb so it doesn't slide, and I've measured that's 1 1/8 inches. I'll do it one more time just to check my work and make sure I'm not on some fluky place. That's why there's 2 holes. Yeah, I just gotta hit it. There you go. Find the fiberglass. There's the fiberglass. No, 1 1/8 inches. So from the bottom of the G10 to top of deck, is 1 inch, which we measured, and then from there to the underside of the plywood is 1 1/8 inches. So 2 1/8 inches of thickness there. So we've cut away the fiberglass that was there, the old fiberglass, and now we've hit it with a grinder. We ground it down to a feather edge. You can see where the old tang the reinforcement bar pulled into the existing deck and did some damage there. We're gonna have to reinforce that little piece, but the surface is completely roughed up. We've hit it with really coarse paper. The last paper we used was 20. The paper before that was 30, and it's like having big rocks glued to a piece of paper. But it's what it's take to grind away the bad fiberglass. So now we have a nice surface to put new resin against.
Awesome. Let's let you check it out.
So the corners are rounded so that you don't dig in and snap them off. You can keep the load on a straight edge. We'll have to clean it up with alcohol, make sure, and we'll sand one side of it where the epoxy is going to go.
Okay.
Then you've got your base for where the bracket's going. So you can see the light. Here's where the bracket's going to come through, roughly where my fingernail is. I'm going to have to check that measurement one last time tomorrow. Bring a drawing home and check it. Oh, do you have the drawing here? Yeah. I'm going to have to tell them to take an 1/8 inch off of there. Give us a little more margin. All right. 2 1/8. Yeah, that's exactly off the face. Yeah, I think I got a little optimistic. Well, there's an angle to it. Yeah, I think that's gonna have to move an 1/8.